Hi there, I'm Paul Belflam and this is Industrial Organization. In this presentation I want to explain briefly how to derive the monopoly pricing formula. In terms of learning objectives, we're still reviewing some important microeconomic notions. Here we focus on the monopoly pricing formula, which is also called the inverse elasticity rule, and we will introduce a very important concept to measure market power, which is called the learner index. If you want some background reading, what we are presenting here is also presented in section 222 of the textbook. Okay, so we have a monopoly firm and we need to define it in a very broad way. First, we define the demand that this firm is facing. We have a downward sloping inverse demand curve, which we call P of Q. Q is the quantity and P of Q is the maximum price that consumers are willing to pay to obtain this quantity. It's of course a negatively sloped function, as there is a negative relationship between the price and the quantity demanded. Now, in terms of costs, we specify a cost function, C of Q, that tells you the minimum total cost that is necessary to produce some quantity Q. We will rely a lot on the marginal cost, the increase in cost that follows a tiny increase in quantity, C prime of Q. It could be constant, it could be upward sloping. We are not making any further assumption here. Now, what we want to solve is the monopoly problem, okay, which can be defined as the monopoly choosing the quantity that maximizes profit. Profit is usually written by the letter pi, so pi of Q is the profit for a given quantity Q, and it's computed as the difference between total revenue and total cost. Okay, so before we go there, let me remind you of a very important concept, the concept of the price elasticity of demand. Okay, you've seen this already in your very first economics class. It measures the change in the quantity demanded of a product in relation to its price change. Okay, so we use the letter eta here, and we take absolute value because we want to have a positive number. This is a convention that we take. And you see, you probably remember, we take the ratio between the percentage change in quantity, delta Q over Q, given a percentage change in price, delta P over P. So basically it tells you if we increase the price by 1%, by how much will the quantity demanded decrease. Okay, so the two ratios here have opposite signs, and that's why we take the absolute value. Now, if I rearrange this fraction, I can write this in this way. It's 1 over the ratio delta P over delta Q times P over Q. Now, you know that the elasticity is measured at a given point of the demand. So if we want to be extremely precise, we take this change in price and this change in quantity as small as possible. Okay, so here, if we have infinitesimal changes, we're going to use the concept of derivatives, and the continuation of this, if you want, in a continuous term, is this fraction here, 1 over P prime of Q, so that's the first order derivative of the inverse demand, times P over Q with the sign minus here. That defines the price elasticity of demand. Okay, so keep that in mind because we are going to use this now. Right, so now let's go back to the monopoly problem. Okay, it's choosing the quantity Q to maximize this profit. We know how to do that, right? We just take the first order derivative of the profit with respect to the variable that the firm is choosing, and this is the quantity. So if we take the first order derivative with respect to quantity and we equate this to 0, we have what is called the first order condition, and that will tell us what quantity the monopoly should choose to maximize profit. So the quantity that solves this equation here is the profit maximizing quantity. Okay, now let's take the derivative of this with respect to Q. Q is here in the price function as well, and thirdly in the cost function. So that is going to be reflected in the derivative. Okay, so first of all, here we've got a term of, where Q appears 2 times, so it's the product of 2 functions. And you remember, to take the derivative of a product of 2 functions, we have 2 terms. We take the derivative of the first term times the second, and then we take the derivative of the second term, which we multiply by the first. Okay, so this is what we have here. Derivative of q is 1 multiplied by the second function p of q, plus derivative of the second function p of q, that's p prime of q, which multiply by the first function q. Okay, in economics terms, we have the two components of the marginal revenue. If you sell one more unit of the product, you're going to sell this unit at the price P of Q. But as you know, if you want to sell more, you're going to have to decrease the price on all the units you were selling so far. And this is this second term here, which is negative. P prime of Q is negative. Okay, so marginal revenue should be equal to marginal cost. This is the derivative of the total cost, which is here. Okay, so nothing really new for you here. Now, the rest is just playing around with this expression here. The first thing I do is to put c prime on the left-hand side and q times p prime on the right-hand side. This is what we have here. And the last step consists in dividing through on both sides by the price p of q. Okay, and we come up with this final expression here, okay, where on the left-hand side we have what is called the learner index, or the markup. So you see on the top we've got the difference between the price and the marginal cost. So this ratio is larger when the price can be set higher with respect to the marginal cost. And to have something in percentage, we divide by the price. And on the right-hand side, and this is why I spent some time on the previous slide to define the elasticity of demand, what we have here is just the inverse of the elasticity of demand, 1 over eta. Okay, so we've established that by solving its monopoly problem, the firm ends up equating the learner index, the markup, okay, to the inverse of the elasticity of demand. Okay, so we just note this lesson here. A profit maximizing monopolist increases its markup as demand becomes less price elastic. Okay, so what does that mean? If the demand becomes less price elastic, it means that eta here decreases. If eta decreases, 1 over eta increases. And if the right-hand side of the equation increases, so must the left-hand side, meaning that this ratio here must increase, or in other words, that the markup increases, or again, in other words, the firm is able to set a price even above the marginal cost, or higher than the marginal cost than before. And this makes sense, right? If the demand becomes less price elastic, it means that the consumers are less sensitive to a change in price, meaning that the firm can increase its price without losing too much demand. Okay, and that actually confers to the firm a larger market power, and the market power is exactly defined as this capacity that the firm has to raise the price above the marginal cost. Okay, and as we've already discussed, and as you know, in a perfectly competitive market, firms don't have any market power. The price is equal to the marginal cost, and this means that the ratio here, the markup, is equal to 0. This corresponds to a demand that each firm faces, which is infinitely elastic, meaning that consumers react extremely sensitively to any price increase by any firm on the market. Okay, so in a perfectly competitive market, there is no market power, but for a monopoly firm, which is the only one on the market power is positive, and I repeat, and this is the concluding remark here, it's inversely related to the price elasticity of demand. That's it for now. Thank you.